Question 34. The table shows future value interest factors for an annuity of $1. So future value interest factors. Lynn invests a lump sum of $21,000 for 7 years at an interest rate of 6% per annum compounding monthly. Yemi wants to achieve the same future value as Lynn by using an annuity. Yemi plans to deposit a fixed amount into an investment account at the end of each month for 7 years. The investment account pays 6% per annum compounding monthly. Using the table provided, determine how much Yemi needs to deposit each month. So the difference between these two situations between Lynn and Yemi is Lynn is investing a lump sum and Yemi is investing in an annuity. So for a lump sum, all we do is use the compound interest formula, and then for the annuity, we use future value equals present value times future value interest factor. So let's start with Lynn. So for Lynn, we are using the compound interest formula. So her future value is going to equal her present value, which is 21,000 times 1 plus. Now, this is our rate. Let's look at the data. So Lynn is getting an interest rate of 6% per annum, compounding monthly. So we need to turn this percentage into a monthly percentage. So we're going to do 0.06 over 12 to get your monthly rate. And then it's going to be invested for 7 years, but once again, compounding monthly. So we need to turn those years into months. So it's just going to be 7 times 12. Now, if you put that into your calculator, you're going to get 31,927.76236. I'd just like to keep all the decimals in there to prevent rounding error. It's probably not really going to make much of a difference, but this is just a preference of mine because we want to get the exact number that Yemi needs to invest. So now that we have the future value, we can look at Yemi. So the formula for this, I said it earlier, but I want to tell you where it comes from. So when we look at the table, it says it's a future value interest factor table. Now they can give you a future value or a present value table. But for a future value interest factor table, we need to see what they're going to multiply that by and what that's going to be equal to. So I like to look at the future or present value of the table, and that's what's going to be at the front of our equation. And so the other one, in this case present value, is what's going to be multiplied by the interest factor. And so let's say they were to give you a present value interest factor table. We would put the present value at the front of the equation, and the future value is what's going to get multiplied by the number from the table. So for Yemi, it's future value, so we're going to be using this formula. Now, to choose the number on the table, we need to find the rate. So the investment account pays 6% per annum compounding monthly. So the rate is in per annum, so years, and we need to turn that into months. So that is going to be 6% over 12, which equals 0.005, which is this. And then our N, our number of periods, is 4. So each month for 7 years, but once again compounding monthly. So we need to turn these years into months. 7 times 12 equals 84. So that is this number here in the table that we need to use, 104 point da 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 da. Now if we just put it into the formula, the future value, which we got from Lynn, is going to be 31,927.76236 equals the present value times 104.07393. And let's get rid of all this. And so the present value is going to be $306.78 to 2 decimal places.